So today we'll start with module 5, which is C for embedded systems. Okay, so in this module here, you will learn about how to write in C language. Okay, before we proceed with C programming, let's look at the C language overview. Okay, so first thing first, let's look at the pros and cons of using the C language. Right, so if I compare the C language to assembler, so the C language is fairly efficient compared to assembly. Alright, so in terms of the programming, the C, because the C is a high level program, so it is fairly efficient compared to assembly. Why? Because for the assembly you need to know the hardware architecture, but for C, yes, you still need to know the hardware architecture, but it sometimes the hardware architecture is will be done by the compiler. Okay, and then okay, it has a higher abstraction level. Okay, as C is high level programming language compared to assembly, so it has a higher abstraction level. Okay, even though it is a high level program, it still support to access low level hardware. Okay, in which you still can control the use of I/O port and manage them according to what you're going to program. Okay, most important is it is available for most embedded project, in which, for example if you want to use Arduino, okay, you can still program the Arduino by using the C language. For the AVR, for example, okay, you still going to program it in a C language. Also, if you're going to use the ARM, for example, in this course here, okay, we still use the C in order to do the programming. Besides that, we can also use the assembly language to do the programming for most of the embedded project. And last but not least is most popular language, okay, in which it's used many open source project. Okay, the con is, okay, the programmer still must know what he or she doing, okay, such as, okay, you need to have a little if a consideration to a security, the robustness, the maintainability of this. Okay, and then you need to know the lot of synthetically legal program have undefined behavior, and sometimes the C program crashes or worse when something bad happens. So that is the cons of using the C language. So how much C do we need to know? Okay, so first, okay, you need to know how to perform the I/O in C, okay, such as a bit manipulation instruction, and then as well as addressing I/O device in C. Okay, so you need to know this bit manipulation in which you're going to manipulate a certain bit inside of, okay, by using a certain instruction, and then at the same time you're going to get an addressing of I/O device, so you need to know how to perform it by using a C. And then you need to you also need to know how to interface with assembler subroutine, such as you need to understand the step frame, parameter passing convention, and for the best result you have to learn these two. The first one is you need to know the trade-off between the regular subroutine and inline macros, okay, in which that for the inline, it is an inline function that is defined by the inline keyword. Okay, so an inline function is a short function that is expanded by the compiler, while for the macros it is also called a preprocessor directive. The macros are defined by the hashtag defined keywords. Okay, then you need to know what happened when the GNU debugger perform optimization, and as well as the inline assembler. Alright, so the inline assembler is a feature of some compilers that allow a low-level codes written in the assembly language to be embedded within a program among code that otherwise has been compiled from a high-level language such as C or C++. Okay, so this is the what we call here the advantage and disadvantage by using the inline as well as a macro. Okay, you can see here. Okay, so next, okay, to have a good C programming, okay, you should have the following criteria. Okay, the first one is, okay, your programming should be error free, which is the syntax. Okay, so in order to have a error free, okay, you can use this by using a compiler. Okay, so that this compiler here will detect any syntax error. Okay, if the compiler detect any syntax error, and it will give you the error message, okay, in which line that you have a syntax error again. And then the semantic error are more subtle and compile with all warning turned on. Okay, in which in order to have an error free programming, so you need to do a compilation. Okay, so beside that, okay, your programming must perform as expected. Okay, which is error are found with the code review by using the visual inspection. Okay, and your program must be readable. Okay, if your program is hard to read, so it's hard to check for error, means that if your program is not readable, other programmer try to do a troubleshoot of your program, so it become difficult lah. Okay, so must write using a proper style. Okay, make sure that you use the proper style. Last but not least is use a proper indentation. Okay, make sure that you use the proper indentation in your programming. Okay, so C has many traps. Okay, you can use this book as a guide. Okay, so C trap and pitfall by Andrew Koenig. Next, we want to look what is a toolchains. Okay, a toolchain is a set of programming tools that is used to perform a complex software development task or to create a software product, which is typically another computer program or a set of related program. Okay, so this toolchain is actually a set of a tool that are compile a source code from a various source. Okay, so you have a few source code and then you want to compile it from a various source. Okay, and then you link them together to produce executable that can run on your target devices. Okay, this toolchain main consists of a compiler and a linker, which this linker here used to transform the source code into an executable program, and a runtime libraries, okay, which provide the interface to the operating system. And sometimes, okay, the toolchain also includes a debugger, which is used to test and debug a created program. Okay, so this toolchain must or should able to compile assembler, C and C++, as these are the language used most in most embedded projects. Okay, so you need to make sure your toolchain can compile the assembly language, the C language, as well as the C++ language. Okay, so the example of toolchain such a new toolchain that are open source and families use on a Linux, and the other one is a MKEL and all commercial vendors that have their own toolchains. Okay, and then this is a tool. Let's look at the toolchain components. Okay, so this is the component that inside of the toolchain. Okay, the first one is a cross compiler. Okay, so this compiler here is a special program that processes a statement written in a particular program language and turn them into a machine language. Okay, in which okay, you have a high level source or high level language code, and then you want to convert it to the machine code so that your CPU know what you're going to do. Okay, a cross compiler is a compiler that run on a platform A, for example, okay, x86 PC, but it generates an executable for a platform B. Okay, for example, target board. Okay, so there is a cross compiler. Okay, then we have a debugger, as I mentioned earlier. Okay, allow you to see what is going on inside your program while it executes. Means that you want to see the output each of the line of your program. Okay, you want to see what happened. Okay, what is the output of each of your instruction or line of your programming. Okay, and what your program was doing at the moment it crash. Okay, so by using the debugger you can see lah, okay, what happened after you execute the the instruction, or you can also can see, okay, the program, what was the program doing, okay, before it crash. Okay, next we are going to see the typical program generation flow. Okay, so the process of converting, okay, you can see here, this is the figure of the typical program generation flow. Okay, the process of converting the source code, okay, so this is a source code representation of your embedded software into an executable binary image involves 3 distinct steps. Okay, so first you see here you have a source code, or you have an assembly source code. Okay, by using a C compiler, okay, you will turn it to the object file. This is for the C language. Okay, for the assembly source code, in order to convert it to the object file, or in order to turn it into object file, you need to use the assembler. Okay, so this first stage here, okay, each of the source file must be compiled or assembled into an object file. So this is the object file. Once you've done it, okay, then we go to the second stage, okay, in which all of the object file that result from the first step must be linked together to produce a single object file called the relocatable program. Okay, means that the object file from here, okay, from your C language, and you have another object file from assembly language, okay, you need to link it together by using a linker, okay, to produce a single object file. Okay, and then the third stage here, okay, the file that contains an executable binary image that is ready to be run on the embedded system. Once you finish the linking process, okay, it will produce an executable image file, which is this one here will be run. This file here will be run on your embedded systems. Okay, for more details, okay, so this is the function of a linker. So all of the object files resulting from the step 1, okay, this is the step 1, okay, from here, okay, before you do the linking process, okay, must be combined in a special way before the program can be executed. Okay, so the object files themselves are individually incomplete, most notably in that some of the internal variable and function reference have not yet been resolved. Okay, so the job of the linker is, okay, so this linker here is used to combine this object file and in the process to resolve all of the unresolved symbols. Okay, so the output of the linker is a new object file that contains all of the code and data from the input object file. Okay, so you have a file here from your C or C++, okay, and then you have an assembly code, okay, and then you turn it to object file, because this object file here, okay, have a its own code, its own data, its own debug file. Okay, before you can execute these codes here, okay, you need to link them together so that the code file will go to the code file, the data file will go to the data file, while the debug file will go to the debug file. So you come up with the image, okay, executable image binary, and then this one here will go to your embedded system. Okay, so this is the function of this linker here, is to combine this file object, okay, code, data, and debug, okay, and then to resolve all the unresolved symbols. Okay, so we have finished the overview of the C. Okay, now we are going to write the program. Okay, before that we need to know the basics of C language. Okay, so first we are going to see the structure of C file. Okay, so this is a structure of C file. Okay, the C programming can be divided into 4 main parts. Okay, the first part here called as include file and define a variable. Okay, so this is the first part, okay, in which you need this part here. You can include any files that you want to include to your program, and you can define any variable, right? So this is the where you're going to put all these things. Okay, and then the second part, we have the function prototypes and global variable declaration here. Okay, so you can put any function prototype and global variable declaration under the second part here. And then the third part, okay, this is your you're going to put all your function, okay, subroutine or subroutine, okay, all the function programming must put under this part. And last but not least, the last part is your main functions. So this is your main program, so all of your main program will be put under this part. Next, we are going to see the data types. Okay, there are several data types, okay, in C programming, so you need to know what is the size of the data byte, okay, how many bytes, what is the number that support for each of that data bytes. Okay, for the ANSI C, okay, by using the ISO C85, so this is the data type that you need to know. Okay, first INT, okay, number of byte is star. Okay, which is it depends on the system that you're going to use. If your system is 8-bit, so the number of byte is 1 byte lah. Okay, it's 16. Okay, the number of byte is 2 byte. Okay, if you're using the ANSI INT, so similar to INT lah. Okay, the different is this one is for the sign number, which is consist of positive and negative number, but this one here only consists of positive number. Okay, if you're going to use a char, okay, so the size of your data is 1 byte, okay, which is 8-bit. Okay, it start from -1 to 8 to 1 to 7. Okay, because this is for sign number. Okay, if you put the unsigned char, okay, so this is still a 1 byte, which is a 8-bit data. Okay, so the range is from 0 to 255 lah. Okay, if you convert this number here, okay, to hexadecimal, it is starting from 00 to FF. Okay, and then you have, if you're going to use the short INT, so this is the size of this short INT actually is a 2 byte, which is equivalent to 16-bit. Okay, that is starting from -30,000 to 768 to 30,000 to 767. So this is the range of the data. And if you're going to use an unsigned number, okay, which is a 2 byte of unsigned number, by using the unsigned short INT data type, so this is starting from 0 until 65,535. Okay, this is the maximum value Okay, if you convert to hexadecimal, it is a 0 0 0 0 until F F F F. Okay, meanwhile we have a long and okay, which is a total of 32 byte data, sorry, 32 bit data, okay, equivalent to 4 bytes. All right, for the long, so this one is for what we call here sign number, okay, from minus 10 million until positive 10 million something. Okay, if you're using the unsigned long, so this is for unsigned number, okay, of 32 bit data, okay, starting from 0 to 4 billion plus plus. Okay, last but not least, okay, if you're going to have more data, okay, which is the size of your data is 64 bit, okay, so you're going to use the long or ANSI long. Okay, so this is the data byte for the ISO C99. Okay, why should I care about which data type that I'm going to use? Okay, the first thing is you're going to make sure that the performance, okay, you have a better performance, okay, and then overflow does not, okay, you need to make sure that there is no overflow occurs, okay, so that's why you need to know which data type that you're going to use. And last but not least, the constant, right? And there are three methods to find out the exact size of the data files. Okay, the first one is you're going to read the compiler manual. Okay, so inside of your compiler manual, it will say what is the exact size of the data byte for that particular program. Okay, and then you can use the pseudo function size of. Okay, by using the pseudo function size of, it will return you the size of the data type, or you can use the C99 data types. Okay, this is the standard and the latest data type introduced. Okay, what is the ISO C99 data types? Okay, so this is the ISO C99 data types. Okay, so you see this is the data type, and then this is the size of the data, and this is the range from minimum to maximum. Okay, if you put the int 8_t, so means that you're going to use the 8-bit data. Okay, so this is for the signed number, okay, which is starting from -1 to 8 to 1 to 7. Okay, if you put the uint 8_t, means that you're going to use the unsigned 8-bit data, which is starting from 0 to 255. Then if you're going to use the 16-bit data, so you can use the int 16_t or uint 16_t for unsigned number. Okay, for 32-bit data, you can use this data type here. Okay, int 32_t or uint 32_t, and for the 64 data bit, okay, so by using the int 64_t and uint 64_t. Okay, in order to use this data type, okay, you need to simply include this file here. Okay, hashtag include stdint.h. okay, make sure that every time you begin to write down your program, you need to include this file here.